Okay, welcome to part 2 of this question. Just to rehash a little bit, what we did was we found components. We found all the x components. We had a vector here that is in the x. We have a vector here that is in the x and a vector there that is in the x. In terms of direction, this vector is to the west, so we see that we're going to make this vector negative. And then these two vectors are both to the east, and we're going to make those positive according to our directional key that we have already. We also have some y vectors, and so you've got y vectors here, here, and here. So what I want to do now is find the total of the x's and the total of the y's, and so that'll be my step 3 as I go through this vector addition. So step 3 is to find the totals in each direction. So I'm going to do that. So to get the totals, I take F net in the x, and again, F net is just the sum of forces. I see that I have 3 forces in the x direction. I've got a negative 300 newtons. I've got a positive 70.71 newtons to the east, and a positive 173 newtons, 0.2 newtons to the east as well. So I total all that up, and I would then get a total that is equal to negative 56.08 newtons. And of course, that negative in an x direction means to the west. So that's what that direction is. That'll be important later on when we actually draw the vector addition. The net in the y, all I have to do is add up all these highlighted green vectors, right? So those are my y components. 0, negative 70.71, and positive 100 newtons of value there. So when I calculate that, I would get a value that is equal to 29.29 newtons. That's a positive value, and that means then that this is to the north. So I found the totals. Now what I want to do is to take these two totals and draw them in a tip-to-tail fashion. So now I'm taking some geometric vectors, or some algebraic vectors, and changing them back into a geometric or drawn vector. So the second last step is to draw tip to tail. So to do that, I'm going to start my vector at some point. I'm going to leave a little space so that I can go west and north. I'm going to start with the west vector. I always start with the x when I draw these tip to tail diagrams. So that's 56.08 newtons. That is my vector in the x, and so I'm just going to make that green there. So that's 56.08 newtons. I have also a vector that is to the north, and so that north vector then is 29.29. I made that vector a little bit too long, and so I'm just going to erase that a little bit and come back and make that a little bit shorter. Your vectors should be proportional if you can, and so I'm going to call that a 29.29 Newton vector there. So, pardon me, the vector diagram that I drew, I started it at this point, and then I added my 2 vectors, and then this would be the end point of my vector addition. So now I need to draw the result of those 2 vectors. The result is going to go from start to end in that direction. Make sure I put an arrow on it, and then that of course would be F net. Right, so F net always goes from start to end, and the angle or the direction of the F net is always at the starting vertex. So I start the angle right there at the starting vertex